Welcome to the webinar. My name is Khwaja Shams. I'm the co-founder and CEO at Momento. I've been working closely with Daniele for a little bit about just, optimizations that we like to make. And I have deep respect for his technical acumen and innovative personality. But let's go ahead and introduce ourselves a little bit more. Daniele, can you tell us a little bit about yourself?
Yes, so thanks for having me. So I'm Daniele Frasca, an Italian living in Munich, Germany. I am currently the team leader of content discovery working at ProSieben and Sat.1 Media. We are a TV and we are one of the biggest TV in Germany. Before content discovery, I led another team called Syndications, where I gained experience managing large-scale projects and teams. Outside of work, I am also a serverless community builder. And usually I like to push the boundaries and I challenge a lot of things. And yes, people say that I talk too much if you're going around about asking about me. But hey, I'm Italian, so this is what you get. And this is all about me. I mean, I can go ahead, but
No, that's great. And just for everybody, what is ProSieben Sat.1 Media SE?
So ProSieben Sat.1 is a German mass media and digital company. It operates in 3 segments: entertainment, dating, and commerce and venture. I am part of the entertainment segment. And as a team leader of content discovery, we are part of one of the backend team for 2 major products that we're calling publishing and the streaming. The streaming is very well known in the DACH area as a join. So we are serving countries like Germany, Austria, and Switzerland mostly. And because of this, our backend has some challenge in terms of scalability, availability, cache, or everything is a challenge when you're talking about the streaming application, especially because we can have spike anytime for streaming or VOD content.
Oh, and you said you're in charge of syndication before your current role. What like for people who are not in the media industry, what is syndication?
So syndication is the art of syndicating media content to third parties. ProSieben Sat.1 own the rights of certain type of videos. And if, for example, you have a platform and you want to show the content that ProSieben owns, you need to have a contract and everything. And when we are moving this content from ProSieben to third party, this is called syndication, syndicating media content. And usually they are coming with a package of metadata, images, and video, all based on the partner's requirements.
Okay. And you mentioned that you play around with performance and you like to push boundaries. Tell me a little bit about some ways in which you push boundaries with performance.
So usually I get impossible tasks, and these impossible tasks are creating services that need to respond under 100 milliseconds, and they need to serve 1,000 of requests at the same time. If you are into serverless, at some point, even if you're following the best practice, you find some limitations. And this is what actually bring me to use Rust. I'm going around Europe, sometimes also talking about Rust. And the story is very simple. Years ago, I was trying to push and the boundaries, reducing the latency of my services and reducing at the same time the cost. So that usually is very difficult to achieve, because if you're scaling more, you also the costs are increasing. And even if I was already applying all the best practice that you can imagine, batch operation or compressing multiple messages in one messages to stay in the limit of the 256 kilobytes of SQS, SNS, Event Bridge. I hit the limit. I could not do much more. So at the time, I contacted the AWS serverless specialist. And from there, the only best practice left was to change the runtimes. I write lambdas in Node.js, in .NET, Golang, and at the time was the runtime was Rust. So I didn't have much experience. We are talking about now 2-3 years ago with Golang and Rust. So I didn't even have any strong opinion. And I follow the AWS suggestion to go with Rust, because Rust apparently is the fastest of all. And I start working on Rust. And Rust, I mean, if for people, they say that it's complicated, it's difficult to go on board and everything. But Rust, for me, is a bunch of if, else, and loop, like all the other languages. And what they give me in the end of the day is more for less. What actually means that if you're in terms of scalability, Lambda usually process one request per time. And the Lambda power is based on the memory settings. A Node.js Lambda usually must run from 1 gig of RAM. Right? And with Rust, instead, I moved this to 128 megabyte. So this already decreased the price. And we are talking about 40% decrease on price. Moreover, because Rust is a compiled language, it's much faster. So I managed to reduce about 60% in terms of speed. So put all of this together, 60% of speed, so it means the Lambda run much faster, 10 milliseconds. And also the memory setting is the lowest. All of this put together give you so much saving. And the benefits that in the end I got scale, and we are talking about 500 million of requests per month, even up to 1 billion. It's a lot of money saving. And at the same time, what I always say, I get more with less, is because now the Lambda is much faster, and the Lambda, as we know, process one request per time. This Lambda that is stay warm process much more requests per second. So this we are going to the transaction per second, right? So and usually if you're moving to Rust, the transaction per second are triplicated respect to a Node.js Lambda. And this is why I end up working with Rust and looking after the performances, because serverless, even if it's kind of magic, scale and everything, in the end of the day, you really need to push the boundaries. And all these services that you're using, like DynamoDB or S3, Step Function, they all have their own integration latency, but you can tweak the configurations to make, in the end of the day, run your Lambda faster. And this is what I did. That's it. This is actually how I end up working and get interest on the performances in general.
So just so I understand, you reduced the latency by 60%, you triple the throughput of your Lambda per second, and you're able to reduce the amount of memory size for the Lambda at the same time. I'm curious if you considered using Graviton Lambdas as well, or if you had any experience with those with Rust.
This is one of the best practice. So you have these two architectural type. If you read online, you always need to check both. But at the time, the Lambda anyway, with whatever architecture run in 10 milliseconds, even under 10 milliseconds, if you are using the Graviton architecture, you are going to pay much less respect to the x86. So again, I applied all of that. The last, all the best practice that you possibly can think of. And at the end of the day, the only things left for me was to change the runtime. I'm not converting, and I'm not even saying convert everything to Rust. I just use Rust for, let's say, client-side operations where I need to expose an API or a service that you need to do a lot of requests.
Mm-hmm. And was it hard for you to learn Rust from coming from a .NET background? You said it's just ifs, ands, and loops, but
I mean, when I started years ago, there was nothing about Rust on Lambda. I struggled for a week or so. So it took me probably 10 days to have my first wrong way Lambda to make it in Rust. But yeah, it was not so difficult. Rust is kind of verbose as a language, but it's like a .NET V1 20 years ago. Maybe because I'm coming from .NET, I also experienced with Java, with everything. I found Rust not so complicated. I mean, in the end of the day, I do not write services for AWS. I just write a Lambda, and a Lambda for me is just get an input, transform, validations, use the SDK of AWS, and return. So the complexity behind the language is reduced to the minimum, and it's the same language, it's the same complexity that you will get if today you're moving to a different language like a Golang or .NET or even Node. I mean, if you don't know the language, Rust is coming with some borrowing and his own ownership model, but
yeah.
I mean, I got used. So this kind of stuff, for me at least, is transparent. I mean, I can do Node, Go, .NET, I can do a bit of everything, but if you see me coding, actually, I'm kind of, I never remember the correct syntax. I'm always mix and match all these languages. But I mean, end of the day, what is count is the end of results. Reducing the performances, increasing the performances of your services. And the Rust is just a tool.
That's awesome to hear. I like your data-driven background, right? Where you start with a particular goal and then you try to just push the limits, and Rust was something that allowed you to kind of get there. I'm curious, when you were doing this, was your goal primarily to reduce, like you said you got performance increases and cost reduction. When you were optimizing and pushing the limits, were you focusing on either one or the other, or were you just trying to do both at the same time?
Both, to be honest. This is the cool things with moving to Rust. I got the full package. I increased the scalability of my service. I decrease the latency, so better experience for my client, whatever is an end user or is another service. And I also reduce the cost. So I cannot really complain about Rust. They should make it a bit easier for high-level language, but except for that, it's amazing language.
Then in the media and entertainment industry, which is where you work, what we hear so much about at-scale video streaming. Some of my proudest accomplishments have been streaming some of the world's largest events and so forth, right? So, but that gets talked about a lot. And so people hear about the scale challenges of large scale events for video streaming. But I'm eager to learn, what are the other challenges that, with everything else beyond media streaming? And what are the hard problems that you see that don't fit that criteria that gets talked about a lot?
So this is a very good question. So, I mean, video streaming, even if for a live event or on demand, is a crucial part for any media entertainment industry, right? But you're not just going to the website and go straight to the video. Yeah, you have much more before even to watch the video, and there are so many components. So as I say, for example, content discovery is part of one of the backend core. Other teams are account, subscriptions, interactivity. All of us, you can see all of us as one giant backend, and we all have our little domains. So in a normal streaming applications that you have out of there, so you have many services, right? So you have how you load the page. So the page can be loaded synchronously, asynchronously, can be static, can be dynamic, can be multiple way to load a page. You have bookmarks, you have account, you have authorization, you have I don't know, like interactivity, chat, notifications, all these little things, and recommendations with EI. All of these services, and they need to really work together because they exchange metadata, they exchange events to synchronize itself. Because in the end of the day, what you want to give is a similar experience to the user. And we are not just talking the old-fashioned web application. We are talking about TV, the app and the TV, mobile. Mobile is divided by iOS, Android. We have tablets. There are so many different views for the same applications. And behind all of this, there is a world of events, a world of connections. And it's kind of challenging because for example, we aim to have one backend for all our products, just to give a seamless experience to the users. And we also want to cover Switzerland, Austria, and Germany. And yes, so to make it work, there is so much work behind in terms of infrastructure, analysis, development. So it's a never-ending work. Every day there is always something that you can learn.
Got it. And, you know, we talked about Rust, we talked about, you know, all the back-end challenges of providing that interactive experience, like you said, beyond just the video streaming. I noticed that, you know, you also like serverless. I follow you on Twitter and see a lot of your posts. I think you're very pro serverless. Why?
So, pro serverless. So, I mean, the beauty of serverless is the simplicity. And with serverless, you focus on what really matters, just developing features and feature. I don't really need to think about the infrastructure, the security, all these networking things, how to size a cluster. With serverless, you code, deploy, and theoretically just work. In the end of the day, AWS serverless offering is two things. They are taking care of scalability, availability, so all the infrastructure part. And we developer, we are just responsible for putting together all of these services and solve complex problems. And that's it. This is what serverless is. Because I'm old enough, right? So I've been around before the cloud, before even words like unit testing was a thing or something. I mean, I found that developing in a serverless scenario is much easier. So a concept like dependency injections, all the frameworks that we used to have that abstract something for us, you know, like we used to have all this framework even to simulate the queues or events, all these kind of things. You don't need to know all of this. So I mean, they do not disappear, but with serverless it's much easier because you can, again, as I said before, Lambda file, if you're going for the single functionality, it's just a matter of take an input, validate, transforming, call the SDK, and return. you could apply the hexagonal architectural pattern, domain-driven design. All of this still exists, but you don't really need it. And I think I think overall, this is much simpler to work with. Even I have projects with hundreds or almost 200 lambdas. I mean, I don't see the complexity because I do not treat these 100 lambdas or more as a service or something that I want to run locally. I treat them as a single functionalities, and I can rely on AWS that allow me that will work for the communications, right, with events and this kind of stuff. So my work as a developer is focusing on the functions, on the business logic of that function it is. So I have my unit test, I have my integration test, change it, deploy, and test it on the cloud. I don't even need to simulate all the hundreds of services that AWS has because I use the cloud. I mean, it just works out of the box. In the old days, if you have you usually have like a Docker or all multiple maybe instances, they need to be connected. Anyway, it's still complicated because you need to do all the configurations. You need to have all these little services running. Maybe you need to have SQL Server, Oracle up and running on your machines. Now it's all abstract. It's all on the cloud. So I use the real services, and because I don't need to run simulations all day long, it costs pretty much zero doing this because you are almost on the free tires. So to answer your questions, yes, I am a fan of serverless. It's all about simplicity and speed and efficiency. And in terms of scalability, and please interrupt me if I speak too much, in terms of scalability, Lambda just scale. So, I mean, there is a lot of talks with cluster and serverless, against serverless, all this kind of stuff. But if you are moving to an enterprise point of view where cost is relative in the end of the day, with the cluster, even if the cluster theoretically could handle out of the box more connection than API gateway and serverless together, you still need to size the cluster. You still need to figure out because you are not sure if that cluster with that size can actually handle all of the requests. With serverless, I don't know, you go to 10,000 requests per second with API gateway, and you ask now AWS to change the burst quota of the Lambda, and you can do from an instance 0 to 10,000, maybe, no, right? And you can do multi-region, you go do 20,000. So, and without moving a finger. If you want to maybe doing all of this with a cluster, you need to have the autoscale in place, all the rules and everything. Just to test all of this will cost you more than the entire application, and to have these microservices with Lambda running 100% all time. So yeah, it's simplicity.
Yeah, I like the angle of utilization that you're mentioning, because yes, sometimes you can do more in a container or in a very orchestrated server, but you have to have your burst provision for the most part, and the human cost, like you said, right, like to provision and configure ends up making up for any of the infrastructure costs that that might come with it. Now, going back to, we talked about performance, we talked about serverless, we talked about the M&E industry and video compression, but let's actually talk about video compression. So the M&E industry is obsessed with video compression as well. And I think there's entire TV shows about this as well, like Silicon Valley and so forth. But I think you stumbled upon a different type of compression recently. And can you tell us a little bit about how you stumbled upon it, what you tried, and what were the results?
So the story behind about compression was my backend need to have, as every service, use a cache system. the default cache system that everybody goes to is Redis.
Yeah.
And whatever Redis cluster we had, this Redis cluster always crash. It doesn't really matter how big it is. We have giant instances. These instances, not today, not tomorrow, but at some point they crash. And during the years, it's always happening multiple times. So when the cluster, the cache system crash, we have what is called the flood against our downstream services. And because the auto scaling is not fast enough, this is the application go down. The application go down. The user cannot use the applications, and you have a damage with it's not nice for the user at the end of the day. And so because this problem is a recurrent problem, even if it's happening once or twice a year, for me it's a problem. It's one of the problems that I want to solve. So I knew about Momento as a serverless cache system. And so I contact you guys, and we started. This is how everything started. And I did a proof of concept. This proof of concept was focusing on loading out of the cache up to 1 mega of content, whatever this content is. We have to, even if it's just a JSON, 1 mega of content. And regardless, and with Redis, the issue was at scale, and here we are talking about 30, 40,000 requests per second. Even if you have a multi-AZ cluster, this, at the time that you are getting so much data out from Redis, you will generate a lot of connections. So all of this, the cache system become the bottleneck. So, and to design this system, you need to have your Lambda inside the VPC. You need to have all this configuration that I was talking about. So the costs are enormous. And so this is how I approach Momento. Momento, I can use your cache system in my Lambda without the VPC and everything. But as you can say, probably better than me, Momento, you pay Momento for the data transfer. And so if your Lambda is outside of the VPC, you are paying for all the requests that you're sending to Momento. And I am not sending kilobytes. I am moving around terabytes of data. So what was the issues? The issue is, at the time that you're moving terabytes of data and you're getting out for each request, or maybe multiple requests in parallel, we are talking about 300,000, 500,000 requests, and megabytes of data, the cache system becomes a bottleneck. And even if the cache system can work, the issue is the data transfer. And the data transfer, you pay for a terabytes of data because it's a raw data. But and so when I was doing all of these tests, I came up with the compressions. And because if I can compress my data, I can have theoretically a faster data transfer, and I can reduce the storage of my cache system. So kind of a win-win. But the issues with compression is how do you compress? So when I was doing my POC, I used gzip. Gzip used the deflate compression algorithm. It's good, but it's super slow. And after I tried Bison. Bison is the binary JSON, but it's not a compression algorithm. And it turned out to have the binary representation even bigger. So I was actually occupying more storage. So in the end of the day, there was not a right solution until you guys came up with the Z standard compression algorithm. And this one, actually, we can achieve a good balance between compressions, speed, and ratio, because now we can reduce almost I think 90% of this
over 90%.
storage of the JSON that I want to store. And this 90% means, imagine that I have 500 kilobytes JSON, raw JSON. Now I transfer 5. And because this transfer of 5 means that I pay much less data transfer, and the speed of retrieving even this data from outside of my VPC, so me going to Momento instead to go to my local cluster, is way, way faster. And yes, so these are all the stories how we end up with the compressions. So inside in the market, there are multiple type of compression algorithm, and you always need to test all of them and figure out which one is the best. The great things here that Momento apply this compression on their SDK. So me as a user, I do not do anything. I just it just work out of the box. I do my set, I do my get, and everything is working. And in terms of the performances, in the end of the day, I used to have I think 370 millisecond P99 using Redis cluster in my VPC. And with Momento, for this test that I did with all this giant data, it became 390 milliseconds. So that is 20 milliseconds. But the main difference actually was that with Redis, I managed to have 70,000 errors while I was bombarding Redis with requests. My needs is to reach like 300,000, 500,000 requests to the cache system per second. So Redis, while it was scaling up, scaling down, or whatever, right? So there is always these issues. It takes 5 minutes, 6 minutes to get the next node. So to make the story short, even though Momento is 20 milliseconds slower than Redis that you can use locally in your VPC, I could reach 500,000 requests per second without any error, and it just worked. So it just worked because it's just a library that you need to do get and set, and this is it is in the end of the day. And plus, I got the bonus because you guys did an amazing job to get this compression inside the library. Yeah, so
yeah, compression.
I'm not sure if it was clear, but yeah, so compression, I think it's very important.
I think it makes sense. Compression can be very hairy. I think if you do out-of-the-box gzip, a lot of times what we see customers doing is they try gzip with their JSON and they either use the default settings or they turn on the aggressive compression settings, and it ends up taking more time to compress and decompress than it does take to transfer the data over the network. If you tune it a little bit, or if you go to Z standard and use the right level of compression in Z standard, you actually end up spending very little time doing decompression and compression. So you don't end up, you don't end up in a situation where you saved a bunch of time by transferring less data on the network, but then you paid it on the compute side. And with Lambda, you're limited on the compute side anyway, so you want to reduce that regardless. So Z standard tends to be much more efficient. Momento didn't invent it, right? Like this is Z standard, I believe, came out of Facebook. There's a whole lot of work that's gone into optimizing it for text. And then lastly, the other reason why I believe Z standard is a little bit faster or better is that it's designed in the modern world where gzip was made in the days where you can have 32 kilobyte block sizes and so forth. Memory was a premium back then. Z standard uses 1 megabyte blocks, which allows it to have a better compression and more efficient use of multiple cores on the box as well. Those things really help you out in terms of the compression velocity and your ability to get more compression with fewer computes. And it sounds like you liked us having it inside the SDK. I remember you
Yeah.
made a pretty bold feature ask after you tried this on the Rust SDK as well. So tell me a little bit more about, compression being a part of the SDK primitive, and should it be part of every SDK? How would you define it, and why should that be the case by default?
So for me, for example, I think so. No, for one simple reason. I do not, no, the first reason is when I try, I actually did not configure correctly. I don't need to become like also a compression expert. So when even if I use the correct standard, the Z standard compression algorithm, I didn't configure correctly. So turn out that my Lambda was actually slower than the correct. So I did these mistakes. And to be honest, as a client, I cannot spend hours try to figure out this kind of stuff, right? The issues was all of this. I mean, why it should be inside the SDK? First, because you know better. So you know how your servers works and everything, no? Because I mean, every compression can have a burden on the server. But you can, as you say, you can tweak it to have the best of both worlds. And with these compressions, I didn't need to change the code. So I still had to just do my set and get. Everything was pretty much magically. But as a client, I actually save money. So this is, end of the day, what make your implementations a key features. Because, again, I mean, you pay for the data transfer with the Momento. And I mean, if you want to transfer, I don't know, 100 megabytes, maybe super, super cheap. But at the time that you're transferring terabytes, we talk about, I mean, 500 terabytes or more, right? So at the time, so it could make the service super costly that will not justify the usage. And so having this kind of features in the SDK make it great, because now you get the speed and you save the money. And for me, personally, I do not need to use a Redis cluster. There is nothing against the Redis cluster, but my God, it's very difficult to configure, because anyway, once is the connections, once is the wrong commands. Maybe if you're running an mget command that is kind of a scan in a small cluster, works. But if for some reason you have a lot of data, it crashes. You finish the memory, it crashes. Every time there a spike in connections, the cluster cannot make it. So even though we do as everybody, we over provision our cluster, these issues is a recurrent. And Momento just make it super simple. It's just another SDK to use, and you guys make it cheaper to use it. And so now the justification, it makes really sense to drop what we had and move everything else on serverless cache on demand. Yeah.
Well, I'm really happy to hear your experience there. Before we end, I have one more question for you. Are you coming to reInvent?
Oh yeah. So this is I'm lucky enough that my company sent me. This will be my second year attending, and I'm so excited because I'm planning not only to follow specific tools about serverless, and I really hope that this year so we'll have some great announcements, but also as an opportunity in the end of the day to meet all the US people, right? So let's say there are people that you usually host that I call VIP, and that I do not have the opportunity to meet here in Europe. Usually in Europe, are always the same people. I have the honor to meet, I don't know, a few serverless heroes or other AWS community builders fellow. But, you know, there is a lot of people also all around the world, and the reinvent is the opportunity to meet them and discuss. Because in the end of the day, what really counts, so what I'm doing, I'm not the only one in the world, right? So there is always someone with a similar experience that tell you how he built it. And, you say, okay, maybe he has the point. And so this is actually the key of reinvent networking, because you have the opportunity to talk with other specialists in their sector, and you can learn something. And from usually, I always come back with many ideas. And with ideas, usually it gives me the opportunity to build the next generation of my serverless applications. Yeah.
That's awesome. Yeah, I think meeting some of the heroes and community builders and the community is my favorite part of reInvent as well. I'm looking forward to seeing you. I'm looking forward to seeing a lot of the EMEA heroes that they may seem local to you, but it's harder for me to read them. So I like the fact that we get to meet the global community of heroes and community builders and just customers that I can learn from. So I'm super excited. It's only in 2 weeks, and excited to see you there. And yeah, and thank you so much for being here today, Daniele, and thank you for all the content that you write on so many great topics. And please keep going, and we look forward to learning more from you going forward.
Thanks for having me.